Okay, this is for 7 notes. We're talking about inverse trig functions. So we're going to learn about inverse sine, inverse cosine, inverse tangent. We'll compose some of these and do some application. Alright, so let's start with inverse sine. Inverse sine looks like this. We know that here's the regular sine function. We'll call this f of x equals sine of x. And you know this keeps going on forever, right, in both directions. And that causes a problem for us when we go to do the inverse, though, because keep in mind inverses are reflections over the line y equals x. So the inverses would basically look like this then. It would keep going forever like that. And that's an issue because that doesn't pass the vertical line test. That's not a function, right? If we stick in one value for x, we get out an infinite number of y values, and that's not really helpful for us. So what we're going to do is we're going to restrict the domain and range. All right, and this is on our formula sheet. Let me pull this up for you. On our formula sheet, we have inverse sine, cosine, and tangent. I've got the domain and range listed here for you. Okay, so it makes sense to restrict the domains that we have. For example, here's the sine. The domain is going to be from -1 to 1, and the range is going to be from -90 to 90, so that we don't end up, with, if we continue on, we'll have one x value that gives us 2 different outputs. Therefore, it wouldn't pass the vertical line test. So this is just our inverse sine, just these values here. And we'll hopefully use this function to solve some problems that are meaningful for us. Here's what the book says. The book uses arc sine sometimes, so keep that in mind instead of inverse sine. And same thing, the domain is -1 to 1, and the range is -90 to 90. Okay, so here's an example then of a problem we would do, typical problem, hopefully without a calculator. We want to find the exact value without a calculator of the inverse sine of -1/2. So what I'm going to do is I'm going to write the sine of some angle equals -1/2, because what this is an angle. An inverse sine of some ratio always gives you an angle, because right, if we the inverse switch the domain and range, they switch these 2 values right here. So if we do the inverse of this, which would be the regular sine, we'd have the sine of an angle equals the ratio. So keep in mind the regular sine function does sine of an angle equals the ratio. The inverse does the inverse of the ratio equals the angle. Alright? So I like to just write this down because this is something I'm more comfortable with, I'm more familiar with the regular sine. And then I can say, okay, well, where's my reference triangle? I want the sine to be negative, so I know that the sine is negative either here or here, if I use either this angle or this angle, if I go negative, for example. And I know that I need to use this angle over here. And the reason I know I need to use that negative angle right there is because of the fact that we restricted our domain and range for sine, so our range needs to be between -90 and 90. What that means is the range for this function is the angle. Angle that I get out needs to be between -90 and 90. So sine is always going to be, inverse sine is always going to be, the range is going to be here. Okay? So I know my reference triangle has to be here. Now they said sine was -1/2, so that'd be opposite over hypotenuse. And I'll try to draw this a little bit to scale here. Not much, but so it'd be opposite over hypotenuse. And if I do the Pythagorean theorem on this, I would get the square root of 3 right here. And so this is a special right triangle, and we know that the sine is the y value, so that's why I put this point here. If we look at our unit circle, we can find where the sine is -1/2 right here. Turns out that's -30 or -pi/6 on our unit circle. And you can also tell if this is a 30, 60, 90 based on these values, because this is like s, this is like 2s, and this is like s squared of 3, where s is 1 in this case. So you can notice it's a special right triangle, or you can look at your unit circle, and the angle that you get out is -30, which is between -90 and 90. So that's the answer we're looking for. That's what this equals. Now, here's another example then. If we take the inverse sine of the sine of an angle, these always undo each other. Inverses undo one another. That's what they are. That's the reason they're useful in the first place. So we're going to get pi over 10. Now, the only time this is going to be tricky is when I give you a value that messes with the domain in any way of the inverse sine function. We do have one of those in the homework, and we'll talk about that when we get to. Okay, next is arc cosine. Here's an example of arc cosine or inverse cosine. We know the cosine keeps going, right, forever like that. But once again, if we were to do that, if we were to keep going with the cosine when we reflect over line y equals x to make the inverse, we don't have a function. So we do have to restrict the domain and the range. The range rather. The domain is going to go from -1 to 1. The range, we're going to stop it at pi, so we don't keep going and we violate the vertical line test and the definition of a function. So there's the cosine. Once again, I give this to you in the formula sheet. The cosine's domain is -1 to 1. The range is 0 to pi. All right. So here's what the book says. Same thing I just told you a second ago. Okay. Then inverse tangent. We know inverse tangent looks like this. It's got an asymptote at 90, and then it just keeps repeating, right? Got an asymptote at -90, and it keeps repeating. The problem is, once again, if we reflect this over line y equals x, we end up getting the asymptotes will go here, and this function will keep, doing this. But that doesn't pass the vertical line test. So once again, we do have to restrict the range. So we're going to say the range goes from -90 to 90, and not continue this on. And that is on your formula sheet. Right here, the range is -90 to 90. And so the book says the exact same thing, domain, range. And we can briefly talk about end behavior of a tangent function. If I were to ask you what the end behavior was, you could say the limit as x approaches infinity of the inverse tangent function, which the graph is right here, ends up being pi over 2. Because as x goes big, this function approaches this value 90 degrees. Okay? If I switched it to negative infinity, then the inverse tangent goes to negative pi over 2, back here. Okay, let's try another example then, before we start the homework, with arc cosine. So what I'm going to do is I'm going to give you, actually, what this is an angle, right? Inverse cosine gives you an angle. So I'm telling you the inverse cosine of x is our angle that we're working with. We want to do the 6 basic trig functions of this angle. So we have the cosine of this angle. I'll just call it, I guess I could call it theta to help me, to save me a little time from having to write this. But the trick is going to be setting up your reference triangle. So we know we're talking about the inverse cosine of x. So I need to draw a triangle. Now where do I draw that triangle? I'm going to draw the first quadrant, and I'm going to look at my formula sheet and say, okay, well, what's the range? The range is from 0 to pi. So I know that my triangle has to be somewhere in here, because my angle, which is the range, has to be somewhere between 0 and 180 degrees. So that works fine. And that gives me, x is positive in this case. So I'm going to write this. I'm going to write the cosine of theta equals x, because I'm more familiar with this than this, and these mean the same thing, right? I just switched the domain and range. So the cosine of some theta is equal to x. Well, here's theta, let's say. Cosine is adjacent over hypotenuse, so here's one way to get x right there. We would do adjacent over hypotenuse. Now, the opposite side then would be, if you did the Pythagorean theorem, you would get x squared plus whatever this is, I'll call it b for now, equals 1. We would subtract x squared from both sides, and we would square root both sides. So this ends up being the square root of 1 minus x squared. So there's my triangle to set up, and that's important because when I do the cosine of the angle, we already know that's x. But when I do the sine of this angle, which by the way theta is inverse cosine, so I'm really doing sine of inverse cosine in this case. But I'll just call that theta for now because I can. Equals opposite over hypotenuse, so that'd be the square root of 1 minus x squared. The tangent then would be, once you get this set up, it's pretty easy. Opposite over adjacent, so it'd be the square root of 1 minus x squared over x. And then this is the reciprocal, so secant is the reciprocal of cosine, and that's just going to be 1 over x. Cosecant is the reciprocal of sine, and that'd be 1 over the square root of 1 minus x squared. And then cotangent is the reciprocal of tangent, and that'd be x over square root of 1 minus x squared. So you're going to have to do problems like this, a little tricky with the algebra, but we'll work through it in the homework. So let's try the homework now and see if we can make sense of this.